Okay guys, here is your last elimination video, unless you need more. So, once again, we're still in elimination. This one is going to be very, very, very hard because it's going to be hard to make a letter go away, and then at the end you're going to see something happen that's going to make this sort of a trick problem. So follow along, I'll try to be clear and see how it goes. So remember, in elimination, our goal is when we add the two together, adding up and down, we want one of the letters, one of the variables to go away. And right here, nothing's going to go away. So, as we learned in the last video, we are allowed to multiply any equation by anything we want as long as we do it the whole way across. So, think, is there anything we can multiply this row by that would make this and this cancel, or this and this cancel? So our goal is we'd like to make this become maybe a negative 3 to cancel that out, or make this become a positive 6 to cancel that out. And it's not going to happen. So we're going to have to do something to both rows. So I think in the last video we canceled out, what did we cancel out? We canceled out the x's first. So let's cancel out the y's this time. So when you look at these y's, think of a number that 4 and 6 can go into. You might think of 12. So what we're going to do is we're going to try to make this row be positive 12 and this row be negative 12. So what we're going to do is we are going to multiply this whole entire row here by 3. The reason is, when we multiply by 3 right there, we're going to make a positive 12. Then, we're going to multiply this whole entire row by 2. The reason I'm doing that is if I take this whole row by 2, this is going to become a negative 12. Remember, our goal is to make something cancel out. We don't really care what happens to the x's and the numbers. We'll take care of those later. So, I'm going to rewrite it. So, I'm going to take this entire row here and multiply by 3. So, I get negative 6x, 12y equals 3. Down here, I'm going to take this whole row and multiply by 2. 6x minus 12y equals 18. So now we're to where we want to be. If you remember, our goal before is that when we add these, we want one of the letters to go away. So here these y's are going to cancel because in the previous problems we made x go away, so we thought, heck with it, we'll just make y go away. But now we're going to go where it's a trick. So I wanted to show you what happens sometimes when you have to multiply both rows by something to get a letter to go away. What you're going to notice here when we add, guess what? Both letters go away because negative 6 plus 6 is gone. 12 plus negative 12 is gone. So we have nothing over here. Now over here we get 21. Now hopefully remember back in some of the old equations we did, what happens when all the letters go away? We have 0 equals 21. All the letters are gone. So it's one of those trick questions, which means you're going to have two choices for answers. No solutions or all real numbers. Now, every book calls this something different. You'll see the word identity, you'll call infinitely many solutions, all real numbers, all kinds of stuff. We just call it all real numbers. So here's how you tell which one it is. If this line, when the letters go away, if this line is true, it is all real numbers. If this line is false, it is no solutions. We did this on inequalities a while back with greater than and less than signs. Obviously 0 does not equal 21, so it's false. So the answer is no solutions. Once you get the hang of it, that's actually pretty simple because now you don't have to figure out the x and y, and you don't have to plug back in to get the others. So, if all the variables cancel out and you get a false statement, no solutions. If this come out to be 21 equals 21, or 8 equals 8, or negative 5 equals negative 5, if it's any true statement, you'd say all real numbers. Now, if back in our graphing section from earlier in the week, what this would look like, no solutions, in the graphing world, no solutions would be the lines are parallel to each other. That's what no solutions looks like when you graph it. There may have been a couple of those on the worksheet from graphing. What does many solutions or all real numbers look like? What that would be is if you graph two lines, and they actually ended up being right on top of one another. They cross many, many, many times. So that's what all real numbers or many solutions look like. Hopefully that helps out, and like I said, this is probably the hardest you will see on all the worksheets. Hopefully that helps.